Give me a couple tests.
Test. Good evening. We're making sure that before we really get started here.
Okay, we know this.
Test. Can you hear me now? All good?
Yep.
All right. So, good evening, everyone. Welcome to another Southfield MISEC Tech Talk. We'd like to thank Brown Iron House for hosting. We would like to welcome Chris Jenks, who will be giving us a presentation on intrusion detection honeypots on an SBC.
Okay, so if you guys can hear me in the room, say something. Close the door. This will be loud out there. So, I guess the first question is who am I? All right, my name is Chris Jenks, go by RATTIS. I'm one of the OGs. I haven't presented for MISEC since April 2012. So yeah, I've been around for a while. So the talk today is going to cover a couple things. We're going to talk about the need for intrusion detection honeypots, how they're different than regular honeypots, and why you should probably want to put one somewhere in your network, at least for monitoring purposes, if not for more. We're going to talk a little bit about the history of honeypots, just a really quick overview of them. We're going to talk about Open Canary and why they can work for my needs. If you're familiar with Think's Canary and Canary servers, we make a honeypot too. And it's a really nice honeypot. It's just wouldn't work for my needs. We'll get into why. And then we'll go over what I built based off of taking things from a Black Hills course and a book by Chris Sanders, making some modifications, making it my own, and some of the stuff I've done. And if I would have had a proper travel network set up, I would have brought it with me, but it's actually sitting at home, not my network, doing its job. So, first up, I had an issue I needed to scratch. Right? That's the way all problems start. You have a back scratcher, it's not reaching that one spot you need, so you go and build a better back scratcher. Now, I have constraints, right? So let's talk about the original problem. Originally, the place I was at, we could see between segments, right? I could see traffic going from the user VLAN to the server VLANs, to the test lab, out to the internet, every which way. What we couldn't see was traffic going back and forth between the user computers on the same network, or servers on the same network, right? So we did a launch one day. Were you there with us when we point to another person in the room? You get back and that pipe, launch and that pipe is going on. And it was one of those like quarterly team lunches where the entire team, the entire intel team walks out for lunch. We get back, everybody's freaking out because that pipe is going on. So one of the things that happened in that pipe was device to device on the same VLAN, talking back and forth and spreading over the SMB ports basically. So how do we view that? How can we look for that? How can we see that? Well, there's no real good tools out there. You can put in network sensors, it'll catch it as the traffic goes by, maybe. You can put in a honeypot, and if somebody's talking to it, you can put an IDS in there, but again, the traffic's not going directly to it, it's going by it, right? And if the attacker's on your network and sees it, they're going to say, this is a device that's designed to catch me, I don't want to touch it, and I'm going to bypass it. So you want something that blends in, you want something that looks like that environment. We'll get back to that in a few minutes. But the biggest issue that I had with this project at the time, legal did not like the term honeypots at this company. They were insistent that a honeypot is an entrapment device, and if we had them on the network, we were inviting attackers to attack us, and they could legally defend themselves saying that they wouldn't have done it if that device wasn't there. Now that's a BS answer, but it's actually based off of FIPS. So the next thing is even though it was a very large company, our budgets were very thin and very cheap. Training situations, you would have the entire department put in for training at the beginning of the year. Maybe 10 people got to go. Out of 78 people that we had the team, right? But at the same time, when you're talking about large budgets and large amounts of money, you've got to pick your battles. Even in smaller companies, you've got to pick your battles. So I needed something I could do this on the cheap. And at the time, the Raspberry Pi was still about $100 all in for the case, the power supply, all the parts. Okay, so I need something that could be cheap, something I couldn't call a honeypot, and more importantly, something that didn't return a login page back to the attacker. So it's extremely limited to 0. And we'll see at the end, I kind of broke the rules a little bit, but not by much. So something that they couldn't log into and then claim entrapment later. Okay. So let's talk about honeypots real quick. Going back to 1974, which is or 76 actually, when FIPS 39 was written. The definition is actually on the page. The deliberate planting of apparent flaws in a system for the purpose of detecting, attempted penetration or confusing an intruder about the flaws to attempt to exploit. Right? So you're basically, the federal government came out in 76 and said, before the term honeypot was ever coined, came out and said, this is what we have, this is what we mean by entrapment, you can kind of do it, this is the definition of it, right? But you should still be able to argue they were on our network to begin with. We gave them something to distract them long enough to actually say, this isn't what we're looking for. Now, fast forward about 10 years, 1987, so 11 years actually, you have this guy named Cliff Stoll working out in California. His research project ran out, they didn't want to fire him, so they put him on the computer network and said, congratulations, you're a computer administrator, go out to computer administration things. Sorry, it's allergy season, my nose has been running all day. So they found this guy on Cliff Stoll's network at the university using time, but not paying for it because it's a time-shared system. So you have to pay for your time on the mainframes or on any of the servers. So this guy is using, I'm giving the high-level view, large spoiler, sorry. So this guy's coming in from somewhere using the time and not being billed for it. So he's going to hunt this time. And it turns out it's espionage. And this guy's logging in from Germany and using it as a hopping point to other places, using it for different things. Well, the problem they had is they needed to keep the guy online long enough to trace through the old telephone switch network, which were rotary dials in Germany at the time. So they could trace everything back to Germany, but this guy would drop off before they could get somebody to the central office where all the telephone switches were, trace down which aisle it's in, trace down which cabinet it's in, trace down which rotor set it is, and then trace it down the rows going into the person's house. So his entrapment method, and I'm going to use the FIPS definition now, his entrapment method was to create a bunch of fake government documents. And this guy comes in and he starts reading through these documents, and they do the trace and find them all the way back in Germany. And it's like, cool beans, we got this one. The next time I came across the concept of a honeypot, it's still not called a honeypot. It was in a white paper that I read in the ACN library called A Night with Buford. I might be saying the name wrong. But that was by Bill Cheswick, who, if you've been around long enough, one of the grandfathers of firewalls. Wrote the book literally on firewalls and internet security. So he's up late one night in the 90s, watching CNN as we're going into Iraq the first time. The U.S. is going into Iraq the first time after the Kuwait invasion. And he's seeing weird things coming up on the terminal next to him. And he's like, what's going on? So he spends the time, creates a Unix jail. So a VM basically, because that's what VMs were before VMs. You had Unix jails. And he's locked this guy inside this fake environment, this fake operating system, trying to keep him online to see what he's doing, and sharing back to other universities and other locations what's happening, what's going on, what accounts are compromised, what accounts is this guy using. And at this point, we still haven't created the term honeypots, which actually doesn't come around until much later, coined by Lance Spitzner around 97, 99, somewhere in that time frame. So he, in a white paper called Build a Honeypot. And it's the first time that anybody can, when I was researching this for the talk, that's the first time anybody had come up with the term honeypots for what they were doing, for building these devices to delay the attacker, to distract the attacker, that put them in a place where they're not doing damage to the rest of the network, but collecting data off of what's going on. Old school threat intelligence. We know who the attacker is, we're sharing the data with the other companies, we're using our intelligence products, we're writing books on this. So at the same time, you have the deception toolkit, CyberCop, and Back Officer, which were being used as honeypots at the same time the term was coming out. And then a couple other ones that came along later. There's a large project that's still ongoing. They do Google Summer of Code every year called the Honey Nut Project. If you had heard me while we were eating, I said I sent a copy of the slides, which is the same presentation I uploaded into the Discord channel earlier with all the notes in it. I sent that over to a friend at Active Countermeasures. He read through, he's like, this reminds you of when we started the Honey Nut Project. He's like, oh, gee, thanks. And then he's giving me some things to look at for future iterations of what I've done. So, and I like this image. I want to talk about this image just real quick. That was an image that was part of a paper, article, about the oldest honeypot found that's still around. So that was an actual honeypot, per the article, found in Egypt, in the pyramids, or Valley of the Kings, I'm not sure which it was. And it still contained honey that you could eat. It was like 3,500 years old. And it was still viable honey. So, there's been different honeypots out there. La Brea is kind of fun because, like the La Brea tar pits, it slows you down as you keep attacking. So it gets slower and slower as you go deeper into it. But a little bit of a side tangent. So I mentioned I wanted a honeypot, and open canary was a thing back then. I came across it in a book that we're going to talk about in a minute, which led to how I came up with my process. Great honeypot, made by things. My only complaint is it looks like a server, right? So, you can download it easily on GitHub. It's got a walkthrough on how to set it up. It's got all the fun stuff. It's got all these great tools. It's low interaction, and there's the problem. It's providing a server-style login page, either for SSH, FTP. Well, let's just look at the services, right? I can have it look like any one of these servers or multiples of these servers, but it's going to give them a login page, and they're going to be able to log into it. And now you're interacting with it. There's no way legal is going to let us go with it. Even though we were using canary tokens at that job, the management team and legal said, no, you can't do this because they're interacting with it. What part of entrapment are you not grasping? If they can interact with it, it's entrapment. Okay, so what do I do? How do I scratch this? I love playing with Raspberry Pis. I love coming up with different things to do with Raspberry Pis. I love taking other people's projects with Raspberry Pis and bringing them into my own home lab. Well, problem doesn't start by there. We're still scratching our heads trying to figure out how to do this. And I had the first edition of Offensive Countermeasures. The second edition came out. I read through the first edition at one point. And the colors on the screen in the room are really off. But so the blues are looking the greens, which is kind of cool because I love the color. The other one was Intrusion Detection Honeypots by Chris Sanders. And Chris Sanders was one of my professors in college at the time while I was going through my grad program. So it's like, okay, they're talking about all these different type of honeypot activities in the first book. Chris Sanders is talking about building your own honeypots just for detecting intrusions. They're not designed to be heavily interacted with, right? But you can also set them up so they're not interactive. And that's what really caught my attention. So in Chris's book, he's using Netcat as a listener. He sets it up as a repeated listener. Now, the way he did it in his scripts on his GitHub page, he provides backend pages. So you connect to the listener, it will send you back a web page. Not a login page, but a web page. Or it'll send you back an error saying that can't connect. Whatever you want to send, it will send as a static page. So if you want to send it, like do a background and say, show me what your web page is, it'll send it to you. Well, that's great, but that still breaks the rules that I am now stuck within. That one constraint where I can't have anything go back. Well, wait, I don't need to have stuff go back. I can just not do that, have it return no data, and literally let them pound their heads on it. And yes, they will pound their heads on this. I had one of these set up during a pen test. They found the device. And the next day I'm like, yeah, you guys triggered my honeypot. Here's all the commands you ran. Because it copied the commands onto the console. So it does work. It's zero interaction, or kind of. If you do an nmap scan, it will send you back a three-way handshake. But that's all the interaction you do. So like I said, kind of break one of the rules. So yeah, we're gonna walk through building it real quick. Next couple slides. So, and this is what, again, I put these on the Discord channel if you want to go and play with these on your own. There's a link to my GitHub repository. It's not designed to install and run. They're just template files that you fill out as you go. So you got, this is the one that they actually pounded their heads against at the pen test one, pounded their heads against, the literal one. So I've got 2 network cards in this case. I've got an extended card from Amazon, USB to Ethernet. I've got, you could just do it over Wi-Fi too, but I like over wireless. You've got just a Raspberry Pi 4 with 8 gigs of memory. You can go with 4 if you want. I wouldn't try this on 2. Probably need to wait it on 2, but I would at least use a full. And if you want to do PoE, that's up to you and optional. But I didn't have a PoE system set up, and the desk this was sitting on didn't have PoE to the port, so why waste your entire PoE? So I mentioned first you want to build it. So you can either build the device first, put nmap on it, and then do scanning, or if you have another device you can do scanning from, you can use that instead. So you'll see in the couple of upcoming slides, I was doing it from a Kali Purple VM that I have on the network to do a scan of the network that's on. You're going to want to find, for the network segment that you're plugging into, you want to find the top ports that are in your network. So you can actually say, okay, these are the top 10 or top 12, 15 that I want to host off of here to see if anybody's scanning these, to see if anybody's connected to this. You're trying to make your box look like a regular box in the network. And then again, because we're planning for a single board computer, in this case the Raspberry Pi, but you can do it with others. Or you can do it as a VM, as the previous slide said. You're going to want to change your MAC address to, again, make it look like a device on the network. If your network is all Dell devices, or 90% Dell devices, why do you want to have a Lenovo chip? Or why do you want to have an Acer chip as the device that we're connecting to? It sticks out there. There's something fishy. They might come play with it more, but they might also avoid it. It's not like everything on the network. Is this somebody's personal home computer that they plug in today? So, sorry it's a little small. It was much larger on my screen at home. Hopefully it comes through okay on the recording. But in this case, I have 15 devices running on port 22. I have 7 running port 8009, 7 running port 80, a couple of 443s. And honestly, that's what my home network looks like right now. I basically said ignore all the VLANs and just scan everything. And that's what we're going to do. So in my case, I decided to say, in the notes, in my case, I'm going to set this up on ports 22, 80, 443, 8443, 8009, 445, 139, and 135. So We're gonna go out and build. Like I said, the GitHub link, it takes you to the scripts I use as a template. You'll want to follow the walkthrough that's in the README section, put the things in the proper places. You're going to, I like to do headless systems. If I'm not going to be logging into it and surfing the web, it doesn't make it. So I go with the Raspberry Pi Lite OS, which is on Raspberry Pi Imager. Just go down to other OSs, move over. There it is. As I said, hide the MAC address. You do that by adding a file under /boot/firmware/command line.txt. You just add a line to the end. Try to build the name in if you know what the naming convention is for the environment that you're going into. Change the name to look like that. Change the usernames to look like that. And then do upgrades, because while the images roll, there's still a snap in time, and there's been changes to some of the software, so you want to make sure you get the updates. And then we're going to install some additional software. We're going to do NCAT, and there's a couple of different versions of NetCat. In this particular case, it's NCAT, which is the NMAP organization's version of NetCat. There's the original NetCat, which has been deprecated. There is, I'm going off memory here, I think traditional, which is a rewrite and a fork, but isn't really kept up to date. There's OpenBSD, and then there's the NMAP version. So we're going to use the NMAP version because it's the one that's kept most up to date. And if there's other features that we want to add in the future, like we do want to return a page to somebody, we can do that with this version. We can't do that with the BSD version because they took out the -e flag. And then I like tmux and BioBoot because I like to SSH in once and have split screens so I can see one thing on one side, one thing on the other side, make changes in one, and see what happens real time on the other one, looking at the logs. More utils, which you will need for timestamps, for the timestamp command that is in the script. And then LSOF, because I like that a little bit more than netstaff. LSOF -i -P, and it'll give you a list of all the open sockets, what process is running it, and what goes from there. I put all my scripts under /opt as if I'm building them external and they're going to be long running. Other people like to use userlib or userlib local. I got used to /opt years ago, and I just haven't changed. So you create a file, create a directory for it, put the script underneath it. You go in, you make a couple small changes. Right now, if you look at the template file, it's going to have a port array, so there's a string of ports that we want. The GitHub file says port number, number. Just replace those with the ports that you actually want to use. Change ownership, reset the permissions on it so it runs. Make a log directory because it does put timestamp logs into a specific directory in /var/logs. It will create one file for every port that you have running. Again, set the owner. I usually set that to root admin. The user currently on Debian is added to the admin group, so you can actually see what's associated with admin. If not, add yourself to the admin group if you need to, or whoever needs to be added to it. And then again, change permissions. Do some testing. So there is a step to have syscontrol run this. But before you do that, you want to make sure things are running. So I was running originally and not paying attention, forgetting that I need to put sudo in. It's like, oh, half the stuff's starting, half the stuff's failing. What's going on? Oh, and now when this is true, I don't have to do that when it's in daemon mode. I do have to do that in testing mode. So go back through, do some testing, check the logs, check to make sure it's open sockets. Initial build, if you're running open SSH on its normal port 22, it won't start with netcat because it's already in use. If you make it a daemon, netcat will block port 22 because it usually starts before open SSH, which means you can't SSH into it. So you do need to change your port for SSH. I still suggest doing that if you're using 2 network interfaces, because netcat does do all interfaces and sets listeners on all interfaces. Even if you tell the IP address, it will still do it on all interfaces. SOCAT won't. So the next version of this will probably be SOCAT. If you need to kill a process, pkill9 will kill all processes with this name. So in my case, it's pkill9 netcat because the script calls netcat. And then if you want to remove the logs, sudo remove logs. So some of the testing stuff, let's say it's starting the lower port materials, but nothing's actually starting. Why wasn't this working? Oh, I wasn't doing sudo, right? So I'm showing you a failure in my testing process. I forgot, oh, I'm not running this as root, I'm running this as pi, and you didn't put sudo in there so it fits. Turning it into a daemon is really simple. It's just copy that to the right file, and then syscontrol enable in that file. And it will restart on reboot, and you will have a fully running system. Problem is, it doesn't capture everything, right? So if it's not listed on a port, and somebody is scanning, but they're not scanning those ports, it won't capture it. So IP table rules, I know NF tables is the thing. It's new to me, so I haven't learned it, so I'm learning with what I know. It seems to work. The one caveat here is you want to make sure that you do IP tables, get the table set up and saved before you do IP tables persistence. Otherwise, it's going to throw errors at the end because the rule files aren't there. And then if you notice, I flagged the names, so when it does write to syslog, there'll be either IP table 6 or IP6 tables inbound or IP tables inbound based off of which we'll see. And believe it or not, I found things like port 7080 in the firewall logs. Anyone know what 7080 is? Nobody? Okay, everybody's shaking their head now. 7080 is the peer-to-peer Windows update software. So Windows Update now does peer-to-peer, and will look across your network instead of going out to the internet, and it does on port 7080. Well, we're not listening on port 7080. How do we know that traffic's going out? So if they're doing specific attacks and trying to look like their Windows Update process and scanning and see what's out there and responding to 7080, we're gonna miss it. But the firewall rules catch it. So you want to see it, this goes back to our syslog, because otherwise everything goes into the Linux journal, and it's harder to search through, harder to find what you're looking for. I'm old, right? I've been in the industry for 30 years, and then Unix 30 years ago. I'm not changing. In fact, I'm considering going into BST just to get away from systemd. But yeah, so there's the commands to look up your different logs. So there's the Honeypot port 80 listening. I've got highlighted. You can see what it actually is supposed to look like when it starts properly. The script will put the timestamp in there, say that I'm listening on this port. I started at this time, so if it reboots, you know when it rebooted. Or it gets restarted, you know when it restarted. And it tells you it's listening. This is the firewall logs. As you can see, IP tables. And that was actually a NMAX scan that wasn't triggering on the Honeypot, but triggering the firewall logs because of the firewall rules. So we'll have two ways to catch things, two ways to watch for things. I could tell you how to put these into your SIM. There's 1,000 different ways. So it's going to be up to your SIM provider. Some people do centralized logging. Some people just push it through our syslog. Some people push it to another intermediary device that isn't a syslog server, but isn't the SIM either. And then the SIM reads from that location. So it really depends on what type of SIM you're using. I bring that up because I had somebody ask me, or somebody complain about the WIDS talk I did about 10 years ago using Raspberry Pis. This is great, but how do you set, no, it's 2014, so this is great, but how do I get into the SIM? Well, that's SIM dependent. And it really depends on what your SIM is and how it works. So that's not an easy answer. It's not an easy thing to say. But they're in the logs, you can see the formats, you can see what it provides, and you can pull that into your SIM and write the rules for that. I mentioned the caveats. If you've got a port that's listening already, it'll fail over or fail or if you find it as a daemon, it will block. It doesn't quite catch unmapped scans unless you have IP rules to go with it. So there's a caveat there. With this version of Netcat, the older versions did catch it. This one doesn't for whatever reason. I don't know why Unmapped did that, but that's what they did. Yeah, that's pretty much the notes for that. I did mention already, I did recommend the rules, 0 interaction while I'm returning the Nmap scans. I could set these to drop so they don't get returned, but that's a rule change. So you do get the 3-way handshake. So Nmap does know it's there, it's listening. So that is a little bit, hey, there's this device here. And that's how the pen test firm that I was working with found it. Hey, this came back in an Nmap scan, but what's wrong with this device? Because it's not responding to anything. And they spent a lot of time trying to find it. And when I talked to them the next day, it's like, oh yeah, by the way, you guys triggered my honeypot. What's the IP address? This one? Dude, we spent like 3 hours on that. It's like, why? It wasn't returning data. Why? Because it was there. Yeah, so that's it. Here's my contact information if you want to contact me. Thank you for coming out. There are 2 more slides with references, just pointing back to the books, and a couple of web pages of reference, like the picture came from and whatnot. There are the slide deck on Discord if you want to see the slides in Discord. It's a PDF file. It has all the speaker notes in it, so, which is something I took away from John Strand when I was taking his after countermeasures files. So. And then we'll respond to questions.
How long has this been in production?
This particular one I built 2 weeks ago.
Okay.
I erased everything off the last one when I lost my job a few months ago. I was laid off. It was my personal equipment, so I took it home with me. And because I didn't want to get caught with company equipment or company data on my equipment, I wiped the drive. First one we built 2020. Yeah, because it was just before they shut the plants down. So we had it running for 2 weeks, and then COVID happened and shut everything down. And it sat underneath the desk for months with nobody on the network, so it wasn't very useful there. But I've been running a version of this for the last 5 years. And like I said, I've caught pen testers, I've caught devices doing scans of the network. Every morning I would come in and I'd look at the one that was last version of this one at my last job. Oh, yep, there's the ticket servers scanning the network to see what devices are out on the network and trying to pull them into the managing engine. And that's not going to work here either. But as I check every morning, make sure everything's still working. Yep, those logs are there. That's working. So yeah, it's been a 5-year project. We argue that one every which way. There's a comment about, is it poison or is it venom, right? Most of the forms. And poison's like, think poison ivy, poison oak. You get it when you're someplace you probably shouldn't be and brushing up against it. You've gone off the main trail and you're following this little side trail somebody cut. And now you've brushed up against this poison oak and you got this rash, right? That's poison. Whereas you're walking along and ignoring that rattling sound, you get a little too close to that snake, and it's sunning itself on the trail, and it reaches out and injects you with venom. So, yeah. Anything from on that?
Doesn't look like it, so we close it in. All right, yeah. All right.
Well, thank you everyone for coming out, and thanks again for Chris for giving a great presentation. Everyone watch the Discord for information on the next meeting. We should be hosting a social at One Eye Betty's in 2 weeks. I believe that is Thursday the 27th. So hope to see everyone there. Thanks again for coming out, and I hope everyone has a great evening.